We could be flippant and say we present data because it looks nice, and this isn't wrong. It's sort of true to an extent when we have a bunch of raw data, but it isn't really any good to anyone in this raw form. When we say we present data, we mean is that we provide a kind of visual or graphical summary of the data so we can detect trends in the data. Let's try to interpret this raw data. In this data, just so we can use it as we move along, is a weight of 100 female students in my class. Note that this is only a makeup data and doesn't represent anything. Okay, next we are going to organize these 100 data values into a presentable form. One that always used for this kind of data is frequency distribution. First thing that you want to decide when you can start the frequency distribution is the number of classes that you want. The number of classes on your frequency distribution, and to kind of get there, we first look at the range, and then we kind of think about the amount of data that we have and how big these classes to be and what their class width is So we'll kind of go through that process now. So let's find the range. The range is the difference between the highest data value and the smallest data value. Now here our data value, the highest data value is 80 and our lowest is 23. Where is the 23? Somewhere it's a 20, yeah, there's a 23 somewhere, I forget where. And that's how it looks like. So who weighed 23 kilograms here? So we have this 80 kilograms, the highest one, so minus the lowest one, 23, so we have the range of 57. So as we think about how many classes that we want to keep in mind that we don't want to spread them out too much and have 50 classes for a range of 57. That would become kind of silly. There wouldn't be much data in each class, maybe just one or two pieces of data, but we also don't want to get too small. We don't want 3 classes and then they get all collected into these 3 classes and we don't see the significant shape of the data either. Rule of thumb that we always use is the number of class between 5 and 15. Sturge's law is one way. Sturge's law is one way to calculate the number of classes if you find difficulties to determine the class yourself. This law has been used for many statistical packages to build a histogram. So n here, this is the formula. So yeah, the n here is the number of observation or sample size, which in this case is 100. So log 10 for 100 is equals to 2. So the number of classes k that we will use is 1 plus 3.32 will be 7.6. Then we run up this and become 8. So just to note that Sturge's law has some limitations. So we will use 8. We will use 8 as our number of classes. So we will have 8 classes. Okay, we will have 8 classes, and we draw it here. So the next thing you want to do is to find the class width. So this is the formula for the class width. Okay, here you have the range is 57, and then will be divided by this. The range is the highest value to the lowest value. So the range is 57. And divided by 8. 8 is the classes, and you will get 7.125. And for class width, we've had a ceiling function. So the ceiling function. So the ceiling function means that the ceiling function means to round up the value to the nearest whole number. Always round up it up. So even if this 0.01, we still round it up to 7. And I like a class width of 7 because it's an odd number. We like an odd class. We like an odd class width because then our midpoint is a whole number. I will talk about midpoint later in this video. So keep in mind our class width is 7. Is 7. We want to start our class limits. So next we want to do is try to check our class limit here. So this is our class limits. Our frequency distribution also keeps up with the tally, and I'll show you why we do that in just a second, and then we will count our frequency. Our class limit always start our class limits always start with our smallest data. So here it will be 23. So 23. Our class width is 7. Remember that our class width is 7. So the difference between 23 and our next lower class limit is should be 7. So 23 plus 7 equals to 30. So that's going to be our next lower class limit. And the reason why it is this way, vertical, not horizontal, is because our class width is the number of data values that are in that class. The number of data, not data values, but the numbers that will land right there. So there's 23, 24, 25, 26, 27, 28, and 29. So that's 7. So start with 23, 24, 26, 27, 28, and 29. So that makes 7. So that's why this goes up to 29. All those values, 23 up to 29, is going land right here, and that's what our class width is representative of. So that's why we are adding 7 vertically, so we come up with our class limit. So we'll keep up on doing it until we get at 8 classes. You have 1, 2, 3, 4, 5, 6, 7, 8 classes. So 30, 37, 44, 51, 58, 65, and 72. So and then all continue. So 29 all over plus 7 and plus 7. Alright, so frequency distribution, just a simple frequency distribution, has the class limit and then the frequency. Note here that we have an extra class. Sometimes when we round up the class width, just now we count out how we get a class width of 57 divided by 8 equals to 7.125. We round up it into 7. Instead, we round out into 8. We round out into 7. Sometimes we need to round out. We also can round out into 8 based on our preferences. The most important part is the whole number. You can get 9 classes if you round up it into 8, but it's better to have an odd number for class width, so we can have whole number for midpoints later. Therefore, we will add another class here, since our highest value is 80. Remember that our highest value is 80. If we stop at 8, we don't cover the highest value here. So this class will cover this value. this extra class will cover the extra value here. Always check for this whenever you want to do the histogram or this one. And so we are using tally. We are using tally column here just to make our life simpler, and it's how we arrange our data into this. So taking this raw data, taking this all raw data here, and arranging it into this frequency distribution. And I think the best way to do this is just to start right here with your first data value, okay, 46, and hitting a tally where it lands. 46 land here. So another one, the next one is 51. 51 lands here. Then move on to 31. 31 lands here. So you move, keep going until you get all the tally, right? All the tally for all the raw data. And we'll just keep doing this for every data value and hitting a tally where it lands. When you hit the fifth tally, for example here, you cross like this, indicating it reached 5. So you hit 4. Once you hit 4 and then you want to have another one, you get the fifth one, you just cross for the fifth. There is a mistake here, but I think it's alright. So I hope you can understand. Alright, so I just tell you this everything up. So this one, you should be 5. So not 1 2 3 4 5. So you should ignore one number here, 1 2 3 4, and then hit. So sorry for this mistake. I don't have time to remove the extra number 1. Alright, so I just tally up the data. Hope it's right. Got it into the frequency distribution tallies here, and now I can count up my tallies and record my frequencies. So these are the frequencies. So the tallies are just to get us to be able to record our frequency. So count them up and we get our frequency. So here is 2, 11, 13, 1 2 3 4 5, 17, 1 2 3 4 5, 18, 1 2, 12, 5, 1, and 1. Okay, so there's a frequency distribution of this raw data, excuse me. And now we can look at it and start analyzing it. So much easier now that we can organize it in just this very simple and easy way. So what's next? After we have all the frequency data, what's next? From the frequency table here, okay, from the frequency table here, you can create the histogram. This is what we call as a histogram to represent your data. Remember, and this is very, 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 very important. Make sure that you always write the axis title. Okay, for both x and y axis. Sometimes we don't want to use the range. Okay, so we have the range here. So this is the range. This is range. This is 2. So the second range, 30 to 36, is 12. So on and so forth. Sometimes we don't want to use this range. Okay, we don't want to use this range or class width to represent the x-axis. Another way to do it is by using the midpoint. The class midpoint can be calculated with this formula. So you get the highest boundary, the lower boundary plus the highest boundary. So like for this one, how to calculate the midpoint for this one is 37 plus 43, okay, and then divide by 2. So you get the midpoint here. So this is the midpoint looks like, and you'll get the histogram with the midpoint 26, 33, 40. So remember the higher limit, the midpoint. So 23 plus 29 divided by 2, you get 26. 30 plus 36 divided by 2, you get 33, and so on and so forth. So why we need this midpoint value? So sometimes another type of graph that can be drawn to represent the same set of data as histogram represents is a frequency polygon. This is a frequency polygon, or sometimes we call it as a line bar, line chart. A frequency polygon is a graph constructed by using lines at the joint midpoint. You draw the midpoint first, you draw all this midpoint first, and then you line it with a straight line from one point to another. The heights of the points represent the frequencies. As I mentioned before, the midpoint is calculated by adding the upper and the lower value boundaries of the bin and dividing the sum by 2. So this is the frequency polygon. Or you can present it as a pie chart, donut, or whatever presentation that you feel nice and representative of your data. Of course, you can explore this from Microsoft Excel.